Good morning, everyone, and welcome to the Invasive Species Center's Asian Carp Canada webinar series. My name is Rebecca Schroeder, and I am the Aquatic Invasive Species Specialist at the Invasive Species Center, where I manage our Asian Carp Canada program, and I will be your moderator for today. And for the purposes of reserving bandwidth, I'm going to turn my camera off now, but just a nice little hello. So before we get started, I would like to acknowledge that I am speaking to you today from Robinson-Huron Treaty Territory, the traditional territory of the Anishinaabe, home of Garden River First Nation, Batchewana First Nation, and the Métis Nation. The Invasive Species Center is a not-for-profit organization that connects stakeholders, knowledge, and technology to prevent the introduction and spread of invasive species that harm Canada's environment, economy, and society. We have a lot of great invasive species related resources on our website, including species profiles, best management practices, and tons more. So be sure to check out our website at invasivespeciescenter.ca. Asian Carp Canada is a program of the Invasive Species Center, and it was created to bring together information on the most recent prevention technologies, early warning measures, response efforts, and the overall threat of Asian carps to the Great Lakes and beyond. This project aims to enhance knowledge and education of Asian carps, and we do this in partnership with many agencies across Ontario. And we have a lot of great resources that you can find on our website, which is www.asiancarp.ca. Before we get started with our webinar today, I would like to mention that there will be time for questions at the end of the webinar. So if at any point you have any, please type it into the question box, and at the end of the presentation, I will read them out to our speaker. If you're having technical difficulties, you can also type those into the question box. And lastly, there will be a brief survey following the webinar, and we would really appreciate if you could take some time to fill it out. And now I am pleased to introduce our speaker, Hsien-Yung Lin. Hsien-Yung is a conservation biologist using both quantitative and qualitative methods and decision analysis to support conservation decision-making and natural resources management plans. He is especially interested in studying the connections among different habitats or ecosystems and finding cost-effective ways to manage and conserve threatened species. His current research projects in Carlton University include studies focusing on migratory fish and birds and general conservation issues. So thank you so much for joining us today. And with that, I will stop sharing my screen and allow you to share yours and get started with the presentation.
Awesome, thanks, Rebecca. I will start to share my screen now. So, hello, everyone. Nice to meet you all. I'm Hsien-Yung Lin, a postdoctoral researcher working in Carlton University. And today I would like to share one of our research programs with you all, which is called Using Expert Knowledge to Estimate the Potential of Rideau and Trent-Severn Waterways for Invasive and Endangered Species. And at the beginning, I would like to acknowledge that I'm talking to you on the unceded and unsurrendered territory of the Anishinaabe Algonquin Nation. And first, I would like to thank to all of my collaborators. And from this screen, you can see lots of names here. So we have experts from the universities, from government agencies, and also from indigenous consultancies. As some of you might know, that there are many anthropogenic human-made canals and waterways in the east part of Canada. And today I would like to focus on these two historical canals in southern Ontario, which are Rideau canals and the Trent-Severn waterways. And on this map, you can see the Rideau Canal connects between Lake Ontario and Ottawa River, while Trent-Severn waterways connects between Lake Ontario and Lake Huron. Sometimes these anthropogenic waters provide a novel habitat for native species, but sometimes these kind of waters also provide or open a new door for alien species. For example, if an alien species invaded Lake Ontario, the species might pass through those canals into Lake Huron or Ottawa River, and vice versa. One of the key elements across those canals are lock stations. Of course, because one of the most important reason why we build those canals is for shipping, for navigation. And here you can see a typical structure or graphs for most lock stations. On one side of the lock station, you can see locks. Of course, those are gates which allow the boat or ship to pass. And on the other side, you can see a waterfall or weirs and dams, or even sometimes a hydropower plant, which we use to maintain a suitable water level for navigation. So now imagine you are a fish living in the canal and you want to move upstream or downstream of a canal. You might need to use either through locks or through those waterfalls or weirs and dams to pass through these structures. So in this project, we focus on these two structures, the Trenton Dam 1 lock station and the Kingsto Mills lock station, because these two lock stations are like the front line between Lake Ontario and rest of the water bodies between Lake Ontario and Olive River or Lake Huron. So here you can see the pictures of these two lock stations. On the top, you can see Kingsto Mills lock station, where on the bottom you can see the Trenton Dam 1 lock stations. And as I mentioned earlier, for these, although the structure of these two lock stations looks a bit different, but generally you can see a fish or other aquatic species can use either Route 1, which is through lock gate, or through Route 2, which, sorry, I was wrong. Route 1 is through dams and weirs, while Route 2 is through lock gate. So these kind of structures, the lock stations, are pretty important and will influence the connectivity between the canal and connected water bodies. And it's also influence the dispersal or movement of aquatic species, including both native and non-native species. And for both native and non-native species, we have migratory species and also non-migratory species as well. And in this project, we focus on two groups of fish. One is migratory native species, the American eel, and the other is non-native migratory species, the Asian carps. So the goal of this project, the final question we want to ask is, could habitat in the Rideau and Trent-Severn waterways benefit certain fish populations? And of course, as I mentioned earlier, we focus on two groups of fish, the Asian carps and the American eel. And because I know today I'm talking to people from the Invasive Species Center, so I will put more emphasis on Asian carps, while we wouldn't talk much about American eel. So the ultimate question we want to know is the probability of fish benefited from the canal system. And this probability is influenced by two main factors. The first factor is whether there are suitable habitat in the canal or not. And the second factor is the probability of the fish can move into the system or not. And as I mentioned earlier, the probability of a fish can move into the canal system depends on whether they can move through locks or whether they can move through dams and weirs. And of course, the probability of fish move into a certain system will also depends on the abundance of the fish in connected waters. Like, for example, if we have many Asian carps in Lake Ontario, of course, we will expect a higher probability of Asian carps move into these canals. But I mean, fortunately or unfortunately, so far, we do not have a strong evidence supporting that Asian carps are taking over our Lake Ontario, which is a good news for our environment. But it's not that good in terms of studies or researches, because we couldn't go out and catch tons of Asian carps and see how they move through these structures, because we couldn't do that. There are not many Asian carps, or there are no Asian carps in our system. So that's why we use expert elicitation. So in brief, expert elicitation is a method we use when there is no or very, very limited data. So we couldn't really collect data from the field. And it is especially useful for invasive species in their early stages or for rare and endangered species because there are not many of them. And similar to collecting data in the field, the method we use to extract data from experts need to be transparent, repeatable, and able to reduce potential biases. Now, the biases we will face during expert elicitation will be different from the uncertainties or biases we face usually when we try to, for example, catch fish from the river. Because now the potential biases, they are psychological biases when we ask a question from a person and he or she try to answer those questions. So those are the biases, psychological biases we face. So there will be difference between the ecological biases or uncertainties for a normal, field-based survey or studies. And we use a protocol or a method called ideal protocol, which can help us to reduce those psychological biases. So generally, this protocol, as I show you here, includes 2 rounds of questionnaires. So the I represent investigate, the D represent discuss, E represents estimate, while the A represents aggregate. So during the investigate steps, we ask questions to experts, and then during the discuss steps, we collect those and summarize those answers they provided, and then we have a discussion among experts. And during the estimate steps, we send out the same set of questions again, and the expert have the second chance to revise their answers. And during the last step, which is the aggregate, we standardize and aggregate, summarize all answers provided by the experts in the second round questionnaires, and then we use that as our final product. So now I will lead you through an example to see how we use this ideal protocol to get data from experts. So the first step is investigate. We ask expert questions. Before we ask them questions, we need to identify variables important to our questions. And we need to do it with all experts. So as I mentioned earlier, our ultimate goal is to know what is the probability of fish benefited from a canal system. And this depends on whether there are suitable habitat in the canal and also the probability of fish move into the canal. And here is only one example about the probability of fish moving through a lock stations. This factor will be influenced by many other variables as I show you here. So which includes ecological variables like the size of the fish, the life stage of the fish, hydrological variables like the water temperature, water discharge, and structural variables like the structure of that lock station. And finally, of course, also influenced by the operational variable, which includes something like the lock operation timing, the lock operation frequency, and how lock master operate the locks. And all these variables will influence the passability of a lock for a given fish. So one of the key reasons we need to identify those variables with all experts is that we want to make sure most influential variables are considered explicitly when everyone makes her or his own judgment. And then we also want to provide an opportunity for group learning among experts with different expertise. So our expert includes people who study American eel, people study Asian carps, people study fish movement through anthropogenic structures, and also includes managers from parts Canada. So every expert have different expertise, and we want them and us to learn it together as well. So we use a method called 4-step elicitation for each questions. So what is 4-step elicitation? Which means we need to ask 4 values for each questions. Here I use this as an example. So for example, now we want to ask experts, what do you think is the possibility of Asian carps move upstream, pass through a given weir? Then we ask them, given a vertical wooden weir with 2 meters height, 2 meters per second river water flow with a given operation schemes, please provide your estimate of the highest possible numbers of Asian carp that can pass through this structure. And we also asked the lowest number of carps, the best guess. So what is the best guess you have? So the number of carps can pass through this structure. And also finally, the value of confidence, how confident you are when you give us these numbers. So yeah, in conclusion, we ask 4 values from each questions: the highest estimate, the lowest estimate, and the best guess, and how confident you are. So here is an overall model for Asian carps. So you can see the final question we want to know is the risk of invasion. But in detail, we need to ask many other questions so we can get a sense of what is the risk of invasion. And for Asian carps, in each lock station, we need to ask 6 questions here. The first question is about spawning ground suitability. The second question is about feeding ground suitability. And the third question is about upstream path through locks. The fourth is about upstream path through weirs. And the fifth is about probability of fish moving upstream, considering both locks and weirs. And finally is the ultimate question, the risk of invasion. And as I mentioned earlier, each of these questions will link to different hydrological, ecological, operational, structural variables. So here I will show you some preliminary results for Asian carps at Kingsto Mills lock station. Of course, we have another bunch of results for Asian carps in Trenton Dam 1, but because of the time, I only show you the result for Kingsto Mills today. So now let's take a look at the result we get from the experts, in which we estimate the lock passability for Asian carps through locks and through dams. From the figure on your left-hand side, the y-axis represents the passability of the locks. So from 0 to 100, 100 means all fish can pass, while 0 means zero fish can pass. And from the x-axis, you can see something interesting like the ABC123 or EE222. Those are code names for experts. So each code name represents 1 expert. We use code name to maintain the anonymity. So, and finally, the red horizontal lines represent the average across all experts. And the semi-transparent boxes represent the highest number, the average highest number, and also the lowest number. So on this figure, we can see that most experts think the possibility of Asian carps at Kingsto Mills Station move over weirs are much lower than the possibility for Asian carp move over the locks. Then the next question is, we ask experts, considering both locks passability and weirs passability, what is the overall passability of Asian carp through these Kingsto Mills lock stations? And here you can see the average estimate they give is around 30%. So 30% of the fish can pass through the Kingsto Mills lock stations. And we also ask experts questions about the suitability, habitat suitability. So here you can see we asked them about the spawning ground suitability. So how suitable the habitat within Kingsto Mills Lock Station are for spawning Asian carps, and how suitable those habitats are for feeding Asian carps. And from these two figures, you can see generally those experts think the habitat within and above Kingsto Mills Lock Station are less suitable for spawning, but more suitable for feeding. So in the other words, most experts think the habitat are pretty good for if Asian carp want to feed. So they got plenty of food in the system. But in terms of spawning ground, is not a very good spawning ground for Asian carp. So they can eat and grow in the system, but not necessarily spawning or reproduce. So combining all factors and variables, we ask expert what is the probability of invasion in this system, and you can see the average probability of invasion is around between 30 and 40% of the chance. So after we ask questions to experts, then the next step is discussed. So we try to summarize and hold discussion with all experts and summarize their answers. And we give every expert a chance to say why they provide these answers. So during the discussion, we want to know 4 things from each expert. The first, what are the most important factors they consider when they making their decisions? And second, what is the reasoning behind those answers? If they make any assumptions, could they let us know? And third, what are the most influential uncertainties in their answers? So some expert might say his uncertainty can be climate change because he think climate change might influence his answer. And the other experts might think her answer may be influenced by the assumption for fish, the size of the fish, because fish with different size might have different jumping ability, might have different ability to overcome a barrier. Finally, we ask experts if they have any additional information they can provide and share with other experts. So for example, some people might have unpublished data they collect, or they might have a report that most other experts didn't know. So they are free to share those information with all other experts. So during the discussion, we come up with several issues that we need to make and several changes we need to make to produce the second set of questions. The first one is we try to separate Asian carp into 2 groups. The first one is grass carp, and the second one is bighead and silver carps. For people know about Asian carps, absolutely, grass carp and silver or bighead carps, they have different diet preference. So when we estimate the feeding ground suitability, might be different for this group of fish. And of course, grass carp and bighead and silver carps, they have slightly different jumping ability. So it might also influence our final answer. And then we also discuss some differences between experts' answers. So for example, on the graphs on your right-hand side, you can see the spawning ground suitability for Asian carps. And we saw these figures in previous slide. And in this figure, you can see 2 experts, the golden eagle and the pool bunny. They think this habitat might be more suitable for spawning ground compared to other experts. So most of the four experts think this place sucks for spawning, but 2 experts think, oh, this might be suitable for Asian carps. And we ask them why they give these different answers. And during the discussion, those 2, the golden eagle and pool bunny, they say why they give a higher value is because they only consider egg releasing, while the rest of experts also consider successfully hatch or not. So different experts might have different interpretation or explanation for their answers. So during the discussion, we can modify and refine our questions. So now we have a new definition for spawning, which we define the spawning includes both egg releasing and also hatch. So now in the second round of questionnaires, all experts can really stand on the same ground. So they all know we are going to answer these questions because we know something in common. So not people have different interpretation, but now we discussed it openly so we can have the same interpretation for the same questions. And we also have some other discussions about the passability because experts might put fish in different locations when they consider passability. So now we also sort that out and have a revised version of questions. So the next steps in the ideal protocol is estimate, in which we need to send the same set but revised version of questions to all experts so they have a chance to revise their answers due to some discussion we had before. And right now in this project, we just sent the questionnaire to all experts yesterday. So we are still waiting for their answers. So yeah, so that's why I can only provide you the result from the round 1 questionnaires. And after we got all answers from experts for the round 2 questionnaires, we can summarize and aggregate the result, and we will use those results as our final product and final estimate. So I will not gonna talk through this part because it's about American eel, but I just want to know you that we have slightly different models for eels and carps because 2 different species, group of species have different requirements for habitat and for passabilities. So some future possibilities. So now our current project focuses on American eel and Asian carps. But of course, as many of you know, that there are many other native and non-native species within the system or approaching to the system, such as tench and round gobies. So hopefully in the future, we can, or somebody can use a similar framework to estimate the passability of lux or the habitat suitability for other invasive species such as round gobies and tench. So here are the final points for take home. The first is expert elicitation could be used when there is no or very limited data. And expert elicitation is a way we try to dig out values or data from people or experts' head instead of we collect data from the field. And the second, extract values or probabilities and uncertainties. We can do that during expert elicitation, just like we do in the field. But similar to collecting data in the field, the method used in expert elicitation must be transparent, repeatable, and able to reduce potential biases. So similar to all methods we use when we collect data from the field, we need to do the same thing for expert elicitation as well. And yeah, I think that is the last slide in my talk. Thank you all. I will give this time to question and answers later.
Awesome. Thank you so much, Hsien-Yung. That was a really informative presentation and very interesting. I am going to take back the control, share my screen here, and let's get into the Q&A. So our first question is, what might happen? Oh, sorry. Before we get into that, I do want to mention that we have Valerie from Parks Canada on the line as well, if there are any questions that you'd like to direct to Parks Canada staff. So the first question is, what might happen if you used non-experts instead of experts? Do you not need to show that expert consensus is significantly different from random or non-experts?
Right, man, that is a very good question. And I'm not sure about the correct answer, but in most literature and studies, people tend to do it in a way that we maximize the diversity of our expert groups. So in terms of like for our project, we select experts who doing studies on American eel, who doing studies on Asian carps, and managers from parts Canada, and also indigenous experts. So we try our best to maximize the diversity of expert group, and this method has been proved can improve the final answers. But in terms of how to validate those answers, and also as you mentioned, comparing to non-experts, I'm not sure, and I haven't seen any good method to doing that. But I mean, it sounds like a pretty cool answer that some people can do in the future. Yeah, I agree with you, but sorry, but I couldn't provide a pretty good answer right now.
Great. The next question is, how did you deal with the different responses among fish species?
So before the project, we tried our best to look for data and to group fish into different groups. So as I mentioned earlier, in the beginning of this project, we have one group called American eel, the other groups called Asian carps. But during the discussion and during the questionnaire, we found actually many experts think we should divide the Asian carps into further into grass carp versus bighead and silver carp due to different life history and different mobility. So that is the way we do to consider fish species with different traits or different characteristics. And so which is we review papers first, and then during the discussion, we will also discuss this with all experts that we will decide whether we want to divide the species into different groups because of their different mobility or different life history data. But yeah, it depends on the discussion we have. And it also depends on the question we ask. So for example, for some questions, there are actually no difference for different species. But for some questions, there are very different even within the same species, like the climbing ability will be different for large eel compared to small eel. Yeah, so we need to consider that absolutely, but we will do it through reviewing papers and through the discussion with our experts.
Okay, the next question is, have you seen the results of Scott Reed's work looking at how fish communities differ between the various locks and dams in the Trent-Severn? Did this inform any of the expert elicitations?
Right, yeah, it is pretty good question as well. So yes, I did see the reports from Scott and also from other groups doing research in the Trent-Severn waterways. And I believe these results certainly will inform expert elicitations, especially if the fish you are interested is within the system. But for our project, currently those results are less relevant because there are not many American eels, and fortunately no Asian carps lives in the Trent-Severn system. So yes, we know there are different species living in the system. We have data for darters and we have data for bass movement and yeah, other species which currently living in the system, but they are slightly different with the species we focus in our project.
The next question is, are there any potential biases when getting this information from experts?
Yes, so the most important biases we have, sorry, let me check my, yeah. So usually there are several different biases in expert elicitation. The first one is called anchoring. So anchoring means people tend to anchor on a given initial numbers when they provide their answer. So for example, if I ask a person about her height and somebody saying, oh, I think she is around 160 centimeters high. And I might adjust, I might provide the answer around 160 centimeter. So I will anchor to the initial value somebody provide me. So in order to reduce this bias, we do not provide any initial numbers. So we don't say anything like, we think the passability for Asian carps in Kingsto Mills is 60% in the beginning. We just give nothing. I mean, we don't say an initial number, so the expert can give whatever they think it is correct. And the second potential bias is overconfidence. So people tend to underestimate the uncertainty in their answer. And in order to address these biases, that's why we use the 4 steps elicitation. So we also ask how confident you are when you provide these answers. And previous study already indicate that by asking people how confident you are, it can reduce the overconfidence. And the third one is about availability biases. So which is about the familiarity leads to importance. So for example, expert A might spend his whole life studying the relationship between water temperature and fish movement, while expert B might spend lots of time study the relationship between fish movement and lock station structure. So for expert A, he or she might think the water temperature is the ultimate most important factor in influencing fish movement, while expert B might think lock station structure is the most important factors because they are more familiar with those factors. So we try to reduce these biases to hold discussions. Before we ask questions. So we try to identify all potential variables, including all experts. So expert A can say, oh, I think water temperature is important, while expert B can say, I think the structure of a lock station are important. So then we can gather all these different important factors. So every expert can consider all these factors when they provide their answers. And the fourth biases is group thinking, which is the phenomenon that people tend to desire a harmony or comfortable atmosphere in a group. So this will create biases because sometimes if there is an expert who is very how to say it, his dominates the discussion. Then other experts who is less outgoing or who is more introvert might be afraid of saying his or her own idea. So he might tend to, okay, I will just follow the group since that guy said he thinks that is the right answer. So I will just, saying yes, okay, I agree. But he or she might actually not agree with that guy. So which called group thinking. And we try to reduce these biases by maintaining the anonymity. So none of the experts know why the other answer provided by the other expert, because they all use code name during the discussion and during the questionnaire time. And finally is linguistic ambiguity. So which is linked to one given term can have different meaning for different experts. So as I mentioned earlier, when we ask the suitability for spawning ground, the spawning have different meaning for different experts. While some think spawning only includes releasing eggs, but others might think spawning includes both releasing egg and hatch successfully. So we need to talk about those differences between the experts before we have the revised version of questionnaire to reduce this linguistic issues. So these 5 issues are, probably most common and important issues we might face during the expert illustration.
Our next question is, were there any waterways where Asian carps are present considered to inform the study, like looking to some human-made waterways in the US as like a comparison?
Yes, you're right. So this is a very good question as well. So before we had our illustration, we also gathered many studies from the US because as some of you might know, there are a lot of studies about Asian carps movement in the Mississippi rivers. And I mean, across the Mississippi catchment watershed. So there are many small rivers in that area. And we use those numbers. I mean, we provide all of different studies to experts, saying that, yes, there are previous studies about how Asian carp movement through those anthropogenic structures in the US. But in order to avoid the anchoring biases, as I mentioned earlier, we do not provide a value. So like we wouldn't say, oh, based on a study in Mississippi River, we think the Asian carp passability through a lock might be 30%. We wouldn't say that. We just saying, here are all the previous studies about Asian carp movement in the US and also in other area. And you feel free to check it out. And then before you provide your answers. So those studies are definitely useful. And we did use those studies before the illustration.
Okay, great. So it looks like that's all the questions we have. So with that, I would like to just thank everyone again for tuning in to listen, and another big thank you to Hsien-Yung for presenting today. We did record this webinar and it will be posted on our websites, asiancarp.ca and invasivespeciescenter.ca. And I would also like to plug our invasive species forum that's happening in a couple of weeks, the first week of February from the 1st to the 3rd. Registration is still open and there's spots available. So you can learn more on our website that you'll see here, and you can sign up and register if you're interested. So again, thank you all for tuning in, and please fill out the survey if you have a minute. We'd really appreciate it. Take care, everyone. Have a great day.
See you. Thanks.